Hello, my name is Fuad Kashi. Our today topics is about IMAPs and DNS. A brief introduction about IMAP. What is IMAP? IMAP stands for Internet Message Access Protocol. It's one of the most common protocols used by email clients to retrieve message from a mail server. It's act like POP. Both methods access emails. Actually, email IMAP is the recommended method when you need to check your emails from several different devices, such as phone, laptop, and tablets. Um, its popularity is growing due to the proliferation of mobile devices such as smartphones and tablets. IMAP is ideal for those who need to access their emails on the go or using different devices. IMAP and IMAPs. What is IMAP? IMAP allows you to access your email wherever you are, from any device. When you read an email message using IMAP, you aren't actually downloading or storing it on your computer. Instead, you are reading it from the email service or from the email server. As a result, you can check your email from different services anywhere in the world. Your phone, your phone, computer, or a friend's computer, or a tablet, or whatever. IMAP only downloads a message when you click on it, and attachments aren't automatically downloaded. This way, you are able to check your message a lot more quicker than POP service. It means unlike the older POP3, which typically downloads email to your devices um, and then delete it from the server, IMAP stores email message on the server. This allows you to access your email from multiple devices. Some IMAP features include changes made in an IMAP client are immediately reflect on the server and therefore on all other email clients or interfaces accessing the account. This provides a consistent view across multiple devices. IMAP can be more bandwidth efficient than POP3. For example, you can choose to download just the header of an email um, before deciding whether to download the entire message, which can be useful if you are checking email on a device with a slow or expensive internet connection. On page 7, I have provided some different between IMAP and POP3. Some of them are, um, for example, in IMAP, users can access their emails from any device. But on POP3, by default, emails can only be accessed by the device they are downloaded on. On IMAP, the server stores emails. IMAP act as an immediately between the server, intermediary between the server and the client. But on POP3, once downloaded, emails are deleted from the server unless otherwise configured. On IMAP, emails are not accessible offline, but on POP3, emails are accessible offline, but only the devices they were. Some security consideration for IMAP. With IMAP, emails are stored on the server by default, which could present issues if the server is compromised. However, unlike with POP3, IMAP users do not have to worry about their emails being destroyed if the device they are downloaded on it is lost or damaged. One of the biggest security issue with IMAP is that it transmits logins from the client to the server in plain text by default, meaning usernames and passwords are not encrypted. Another vulnerability associated with IMAP is that it is not inherently compatible with the multi-factor authentication. For this reason, IMAP can be exploited to bypass MFA requirements and make it easier for attackers to successfully conduct password attacks. As mentioned before, one of the biggest security issues with IMAP is that it's plain text by default. Its meaning username and passwords are not encrypted by default. This vulnerability can be protected against by configuring IMAP over SSL or TLS protocol, which facilitates encrypted communication. Same as POP3 and SMTPS, which S means secure protocol of POP3 and SMTP. S on IMAPS stands for secure protocol as well. Um, IMAP over it means IMAP over SSL or TLS, which means it is the Internet Message Access Protocol used with SSL or TLS. Essentially, it is a standard IMAP protocol, but the connection between the um, email client and the server is encrypted for enhanced security. When you use IMAPs, your connection to the mail server is encrypted using either SSL or TLS, depending on the server's configuration and the email client's capabilities. IMAPs typically use port 993, whereas unsecured IMAP typically use port 143. From the security concerns, um, we have to say with the rising concerns over the digital eavesdropping and man-in-the-middle attack, using secure protocol like IMAPs is increasingly becoming the standard for most organization and individual users. Another advantage of IMAP is when setting up an email account in an email client, if you choose IMAPs, the client will automatically handle the encryption process, making its users more user friendly. Configuring IMAP on Dovecot. Um, for configuring IMAP on Dovecot, we we usually working with the main configuration file, which is often located in dovecot.conf or in the directory. Um, with this direction, we're gonna open configuration file with the text editor like Nano or VIM. Then we're gonna edit or add um, enable IMAP protocol by finding um, line protocol IMAP. On page 11, I explained some configuration steps for the IMAP on Dovecot. Hardening recommendation for IMAP on Dovecot. Use encrypted, one of the most important is use encrypted connections. Always try to use SSL or TLS encryption for IMAP connections. Ensure you have a valid SSL certification. You can use certificates from trusted certificate authorities or generate your own using tools like Let's Encrypt. Um, Using firewall is another important step um, to restrict which IP address can connect to your IMAP server. On Windows, use the built-in Windows firewall. If you are not using POP3, disable it in the protocol line in Dovecot configuration. Domain name system or DNS. DNS is the phone book of the internet. Humans access information online through domain names like nytimes.com or espn.com. Web browser interact through Internet Protocol or IP addresses. DNS translate domain names to IP addresses so browser can load internet resources. So when we open a web browser and go to a website, um, we don't have to remember and enter a long number. Instead, we can enter a domain name like google.com and still end up in the right place. To understand how DNS work, uh, we need to know about some keyword about DNS. As as following: DNS server. There are several different types of DNS servers, such as authoritative, recursive, and root servers, which we talk about them more in this chapter. DNS records. These are in tiers in DNS server that provide information about domains. Some common types of DNS records are A, um, 4, 4 A for IPv6 addresses, or MX for mail exchange, or etc. DNS resolver is an application called a DNS resolver is in charge of translating domain name into IP address. DNS caching. Instead of the computer querying the DNS server for the IP address every time you enter the domain name, that information is saved on your computer. Um, so it doesn't have to access to a DNS server to resolve the name with the IP address every time. Um, there are four DNS servers involved in loading a web page. Um, as I said, the first one is DNS Recruiter. The DNS Recruiter is a server designed to receive queries from client machines through applications such as web browser. Typically, the recruiter is then responsible for making additional requests in order to satisfy the client DNS query. Second step or second stage is root name server. The root server is the first step in translating human readable host names into IP address. The third step is TLD name server, or the third server is TLD name server. The top level domain server TLD can be of as a specific rack of books in a library. This name server is the next step in the search for a specific IP address. The fourth server is authoritative name server. The authoritative name server is the last stop in the name server query. If the authoritative name server has access to the request record, it will return the IP address for the request hostname back to the DNS requester that made the initial request. These are the four servers which DNS involved in loading just one web page. To, to understand better how the DNS is working, I explain them very briefly in 8 steps. Step 1, a user types example.com. For example, this is a website, example.com, into a web browser, and the query travels into the internet and is received by DNS recursive resolver. The resolver then queries a DNS root name server. The root server then responds to the resolver with the address of a top-level domain DNS server, which stores the information for its domains. When searching for example.com, our request is pointed toward the .com TLD. The resolver then makes a request to the .com TLD. The TLD server then responds with the IP address of the domain name server example.com. Lastly, the recursive resolver sends a query to the domain's name server. The IP address for example.com is then returned to the resolver from the name server. The DNS resolver then responds to the web browser with the IP address of the domain requested initially. From page 19 to um, 21, I explain how to configure DNS using on IIS or for Windows or bind on Linux machine. Some security hardening for DNS on IIS. First one is secure zone transfer. Only allow zone transfers to specific known IP addresses, like secondary DNS servers. Implement DNSSEC, which means DNS security extension. It is a security protocol created to increase the security of DNS protocol. DNSSEC protects against attacks by digitally signing the data to help ensure it is valid. In order to ensure a secure lookup, the signing must happen at every level in the DNS lookup process. Another process would be firewall. Using firewall for securing the DNS. Another tips is using HTTPS, implementing SSL or TLS to encrypt web traffic. Use a strong certificates, preferably from a recognized certificate authority. Then security hardening for DNS on bind. Um, on page 23, I explained them how. For example, restrict zone transfer. By default, bind allows zone transfer to any requesting system. You should limit this to only known secondary DNS server. Limit the recursion. Do not allow recursion to the entire public. Only allow specific IPs or network that should be querying your DNS server. Restrict query access. Only allow no network to query your DNS server. Using chroot. Running bind in a chroot jail means it runs in restricted environment, which limits um, potential damage if compromised. Thank you for watching my video.